All right, welcome back to the deep dive. Today we're tackling something pretty big and honestly a little mind-boggling. How AI could change the way we approach tough medical cases.
Tough as in those really complex situations where it takes more than one specialist to figure things out, right?
Exactly. Like when you need, multiple expert opinions just to get a handle on what's going on. We're talking multi-disciplinary teams, those MDTs you hear about.
Okay.
But they're not perfect, right? Getting all those specialists together takes time, resources.
Yeah, and even then you've got potential for things to slip through the cracks, procedures not being followed exactly, human biases creeping in.
Right. And sometimes just the sheer difficulty of getting everyone on the same page, communication-wise. So where does AI fit into this already complex picture?
Well, that's where these really powerful AI systems, large language models or LLMs, come in. The idea is that they could make these MDT consultations smoother, maybe even more accurate.
So instead of replacing doctors, we're talking about AI that can help doctors work better together.
Pretty much. And it's not just about throwing more AI at the problem. This multi-agent approach is about simulating the way a real MDT works, with different specialists weighing in. The hope is that this could lead to more reliable, less biased diagnoses than any single AI could manage on its own.
That makes a lot of sense.
Yeah.
But using AI in medicine, especially when we're talking about real patient data, it's got to come with some serious challenges, right?
Absolutely. There's the obvious one, patient privacy. We're dealing with incredibly sensitive information. Then there's the issue of data itself. Getting enough high-quality data to train these AI for these very specific consultations is tough.
And of course, we can't forget the whole hallucination problem, where AI makes stuff up but presents it like it's a fact.
Right, and with something as critical as medical diagnoses, even a small error could have huge consequences. So how do we make sure these AI are reliable?
Well, that's where the idea of these multi-agent systems comes in. Instead of just one AI trying to do it all, you have multiple AI agents, each with its own special role, working together.
Yeah, so they can check each other's work and maybe catch those hallucinations before they become a problem.
It's like having a built-in peer review system, but for AI.
Exactly. And that brings us to what we're really diving into today, MDTeamGPT.
Okay, MDTeamGPT. It's described as this self-evolving framework specifically designed for these complex, multidisciplinary medical consultations. So it's like taking all the pieces we've been talking about, the need for MDTs, the potential of LLMs, and the challenges of AI in medicine, and try and put them together in a way that actually works.
That's a great way to put it. There are a few things that make MDTeamGPT really interesting. First, it uses this multi-agent system where each AI agent acts like a different medical specialist.
Okay, like a virtual team of doctors.
Right. Then, it uses a special method to try and get all those different AI opinions into one unified diagnosis. It's called consensus aggregation.
So they have to agree on a diagnosis.
They try to. And there's this whole structured way they discuss the case over multiple rounds, sharing information and refining their thoughts.
Sounds very organized for AI.
It is. And perhaps the most exciting part is that MDTeamGPT uses two knowledge bases that actually learn and grow over time. One is called the correct answer knowledge base, or correct KB, and the other is the chain of thought knowledge base, or chain KB.
So the AI is constantly learning from both its right and wrong answers. That's pretty incredible.
Exactly. That's the self-evolving part.
Yeah.
It means that theoretically, it could keep getting better at diagnoses without needing humans to constantly retrain it.
So today, our mission is to really unpack how this whole MDTeamGPT thing actually works. How does this multi-agent setup combined with these learning knowledge bases aim to make diagnoses not just more accurate, but also more, logical and explainable? And how does it learn and get better over time?
Right. And we have this really detailed research paper that lays it all out. So are you ready to dive in?
Absolutely. Let's start with the players. Who are the AI agents in this virtual MDT?
Okay, so first you've got your specialist doctor agents. These are like your virtual experts in different fields. There's general internal medicine, general surgery, pediatrics, OBGYN,
OBGYN?
radiology, neurology, pathology, and pharmacy. So pretty much a full team of specialists, all powered by AI.
And these are the agents that actually weigh in on the diagnosis?
That's right. But then you also have these supporting roles. They don't directly diagnose, but they guide the process.
So like the behind the scenes team.
Exactly. There's a primary care doctor agent, a lead physician agent, a chain of thought reviewer, and a safety and ethics reviewer.
Yeah.
It really is structured a lot like a real world medical team.
Okay, I'm seeing how they're trying to make the system mimic a real MDT. So how does a consultation actually start in this system?
Well, it all begins with the patient's information. The system gets the patient's background, let's call it C for short,
Makes sense.
and the specific medical problem or question, which we'll call Q.
So C for context, Q for question.
Got it. And based on this C and Q, the primary care doctor agent decides which specialists are needed for this particular case.
So it's like a triage nurse deciding who to call in.
Pretty much. It's trying to make sure the right specialists are on the case, just like in a real hospital.
Does it just pick names out of a hat, or is there some logic to it?
Oh no, there's definitely logic. The primary care doctor has to explain its reasoning for picking each specialist.
So it can't just say, I think we need a neurologist without saying why.
Exactly. It has to justify its choices, which makes the whole process more transparent.
That's good. So we actually have an example in the paper, right? Can we take a look at that?
Sure. The example is a 1-year-old boy who's showing weakness and some changes in behavior. That's the initial problem, the Q.
Okay, so a pretty young patient with some worrying symptoms.
Right. And based on that information, the primary care doctor agent decides that this could be a neuromuscular disorder. And for this case, it selects a general internal medicine doctor, an OBGYN.
Wait, an OBGYN? For a neuromuscular issue in a 1-year-old boy?
Yeah, it's interesting, right? The paper also includes a radiologist, pathologist, and pharmacist.
It makes you wonder, maybe the AI is picking up on something that wouldn't be immediately obvious to a human doctor. Perhaps there's a developmental or even a genetic angle that links those specialties to the case.
That's a good point. It really shows how the AI might be thinking differently, considering connections we might miss.
It seems like even the initial triage in this system can get pretty complex. So let's say we've got our team of virtual specialists. What happens next?
Now we move into the meat of the process,
Yeah.
the multi-round consultations.
So this is where they actually try to figure out the diagnosis.
Exactly. In the first round, each specialist looks at the patient's information, the C and Q we talked about.
But they don't talk to each other yet.
Not yet. They each give their initial opinion independently, like they would in a real NDT before a big group discussion.
Makes sense. So everyone's got their initial thoughts. How do they start working together?
This is where the lead physician agent comes in. It takes all those individual opinions and sorts them into 4 categories.
4 categories. Okay, lay them on me.
Consistency, conflict, independence, and integration. Think of the lead physician as the meeting organizer, making sense of everyone's input.
Okay, I'm intrigued. Tell me more about these categories.
So consistency is pretty straightforward. It's all the points where multiple specialists agree, we all think this is likely, that kind of thing.
Makes sense. And conflict.
That's when the specialists disagree. Like, I think it's this, but another one says, no, I think it's that.
So it highlights the areas where they need to hash things out.
Right. Then there's independence. That's for anything unique a specialist brings up, something no one else has mentioned. It could be a really crucial piece of the puzzle that others missed.
Like a fresh perspective. And finally, integration. What's that all about?
Integration takes all those different opinions, the agreements, disagreements, the unique points, and combines them into a single summary.
Wow, that's a lot for the lead physician to handle.
It is, but this is key for streamlining the whole process. By the way, the paper actually has a diagram, figure 1, that shows how this categorization works. It's pretty helpful to visualize it.
So the lead physician is like the note taker, the synthesizer, making sense of the chaos of the first round. But where does all this organized information go?
It goes into what they call the historical shared pool. It's basically a record of the consultation as it progresses. And this is where it gets really interesting.
Okay, I'm all ears.
From round 2 onwards, the specialist can actually look back at what was discussed in the previous round. It's like they're building on each other's ideas, refining their thoughts.
So it's not just a free-for-all where they can see everything from the beginning.
No, it's limited to the immediate past. This is what they call the residual discussion structure. For rounds 3 and beyond, they can access information from the 2 previous rounds. There's another helpful figure in the paper, figure 3, that illustrates this.
So they're not getting bogged down with information from, like, 5 rounds ago.
Right. It's all about preventing information overload and staying focused on the most relevant points.
That makes a lot of sense. Now, the paper also talks about algorithm 1. What's that about?
Algorithm 1 is basically a step-by-step guide to the whole multi-round consultation. After each round, the system checks if all the specialists agree on a diagnosis. If they do, great. Discussion over.
Well, what if they don't agree?
Then they go to another round. They have up to 10 rounds to try and reach a consensus.
10 rounds, so it's not just going to go on forever.
Right, and if they still can't agree after 10 rounds, then they go with majority vote. And if it's a tie, well, they just pick an answer randomly.
Seems like a fair way to handle it.
Yeah.
Okay, so we've got our initial independent opinions, then these rounds of discussion where they refine their thinking. What happens in the final stage, the summary and output stage?
This is where we bring in our final 2 agents. First up is the safety and ethics reviewer.
Okay, important role.
Very important.
Yeah.
It looks at the final diagnosis and makes sure there's nothing in there that's, dangerous or unethical.
Like a final check for red flags.
Exactly. And then we have the chain of thought reviewer.
And what does this reviewer do?
Well, it depends on whether the final diagnosis is correct or not. If it's correct, the reviewer summarizes the whole case, the patient's background, the problem, and how the AI team arrived at the right answer. And this summary gets stored in that correct KB we talked about earlier.
So it's like adding a successful case study to the AI's memory bank.
Exactly. But what if the diagnosis is wrong?
Then what? Does the AI just ignore it?
Oh no, it learns from its mistakes too. If the diagnosis is wrong, the chain of thought reviewer creates a really detailed summary of what went wrong. It includes the initial hypotheses, the analysis process, the incorrect conclusion, and most importantly, what might have led them astray.
So it's figuring out where the thinking went off track.
Exactly. And this detailed summary gets stored in the chain KB, the knowledge base for learning from mistakes.
Wow, so it's really taking notes on both its successes and failures. How does all this learning actually help with future diagnoses?
So when a new case comes in, with a new patient and a new problem, the system searches those 2 knowledge bases, the correct KB and the chain KB, for similar cases from the past.
So it's like saying, hey, I've seen something like this before.
Right. They use something called cosine similarity to find the most similar cases. In their experiments, they looked at the top 5 most similar cases.
Top 5, okay.
And the information from those past cases is used to give the specialist agents a bit of a head start on the new case.
So it's like the AI is getting some guidance from its own experience.
Exactly. But here's something interesting. They don't use those knowledge bases in the very first round of a new consultation.
Why not? Seems like that would be the most helpful time.
Well, they want to make sure the specialists are thinking independently in that first round, not just relying on past cases.
So they don't get biased by what's worked before.
Right. They really want those fresh perspectives. And if they can't reach a consensus in the first round, that's when they turn to the knowledge bases for help.
Like a backup plan.
Exactly. The paper calls this algorithm too, by the way, and it spells out how this whole summary and evolution process works. It also mentions that they use OpenAI's text embedding 3 small model for searching those knowledge bases. It's all pretty high-tech stuff.
Okay, enough with the technical jargon. Let's talk results. How did they test this MDTeamGPT thing?
They use 2 datasets that are pretty standard in the world of medical AI, MedQA and PubMedQA.
Okay, and what are those?
MedQA is basically a bunch of multiple choice questions, like the ones you might see on a medical licensing exam. They're designed to test medical knowledge.
So, pretty challenging.
Yeah. And PubMedQA is a bit different. It uses questions from research papers, and the answers are yes, no, or maybe.
So it's testing how well the AI understands complex medical research.
Exactly. And the important thing is, they only use the training data from these data sets to build those knowledge bases. So they weren't giving the AI any unfair advantages.
So what were the results? How well did this whole thing actually work?
Well, the results are in Table 1 of the paper, and they're pretty impressive. On MedQA, using the GPT-4 turbo model, MDTeamGPT got an accuracy of 90.1%. And on PubMedQA, it got 83.9%.
Over 90% on those really tough medical exam questions. That's amazing.
It is. And they compared it to other AI systems, including ones that just use a single LLM, and even some other multi-agent systems.
And how did it stack up?
MDTeamGPT outperformed almost all of them, showing really strong average accuracy across both datasets. There was one method that did slightly better on MedQA, but that one's specifically designed for that kind of question format.
So it's not really a fair comparison.
Right. But overall, MDTeamGPT's performance was really strong.
Okay, I'm sold on the accuracy. But the paper also mentions these ablation studies. What are those all about?
It's like playing with building blocks. They wanted to see how much each part of the system contributes to its success. So they removed or combined different components like that structured discussion we talked about, the lead physician agent, the knowledge bases.
What did they find? What parts were the most important?
Well, one big finding was that having both the structured discussion and the lead physician was way better than having either one alone.
So the way the AI agents talk to each other and having someone to organize their thoughts both matter a lot.
Exactly. And they also found that using both knowledge bases together was much better than using either one alone. It really shows the value of learning from both successes and failures. Interestingly, the correct KB seemed to be a little bit more helpful than the chain KB when used on its own.
So learning from doing things right is slightly more impactful than learning from mistakes.
That's what it seems like. Now, you mentioned earlier that MDTeamGPT is self-evolving. Did they actually test that?
Oh, yeah. They ran experiments with different LLMs, not just GPT-4 Turbo. They used GPT 3.5 Turbo, GPT 4.0, and even some open source models like LMA3.
A good mix of different AI brains.
And figures 4A and B in the paper show how the accuracy changed as the system worked on more and more cases. And basically, across all the LLMs, the accuracy went up as the AI gained more experience, leveling off after about 600 cases. That's clear evidence of learning.
600 cases, huh? That's like giving a medical student hundreds of practice diagnoses.
Exactly. But here's something they didn't expect. Some of the less powerful LLMs, like LAMA3-8B, actually improved faster at the beginning than the really fancy ones like GPT-4 Turbo.
That's interesting. Why do you think that is?
Well, maybe those simpler models benefit more from the structured learning environment of MDTeamGPT. It's like having a really good teacher can make a big difference, even if you're not the smartest student in the class.
Makes you wonder if this framework could be a game changer for places that don't have access to the most cutting-edge AI.
Absolutely. So it's not just about the raw power of the AI, it's about how you structure its learning and collaboration. The paper also looks at how well MDTeamGPT works with different LLMs. What did they find there?
They basically tested how much MDTeamGPT improved accuracy compared to just using a single LLM for each of those models we talked about. And the results were pretty clear. All of them performed better within the MDTeamGPT framework, no matter how powerful they were to begin with.
So teamwork makes the AI dream work.
Something like that. The degree of improvement varied, but the framework always made things better. It seems like it's a pretty universal performance booster.
Very cool. But can it generalize? I mean, can it learn something in one area of medicine and apply it to another?
They tested that too, using what they call cross-dataset generalization. They trained the knowledge bases on one dataset, like MedQA, and then tested it on the other, PubMedQA, and vice versa.
So it's like taking a test on something you didn't specifically study for.
Right. And even when the knowledge bases were trained on a different type of question, there was still an improvement in accuracy compared to not using the knowledge bases at all.
So it's not just memorizing answers, it's learning how to think about medical problems in a more general way.
Exactly. That's a big step towards a more flexible and broadly applicable AI for medical consultations.
So to sum up our deep dive into MDTeamGPT, what are the big takeaways?
Well, it seems like it's a really promising new way to approach these complex medical consultations. By having a team of AI agents working together, discussing cases in a structured way, and learning from both their successes and failures, we could see significant improvements in dystrontic accuracy.
And this framework seems to work across different types of medical knowledge and different underlying AI technologies. That's really impressive.
It is. The goal is to create an AI system that can work alongside human doctors. helping them make more accurate and well-reasoned diagnoses.
It's almost like trying to capture the collective intelligence of a whole team of specialists, but with the added benefits of AI's ability to process information and learn from massive amounts of data.
And to do it in a way that's transparent and accountable, that's the really exciting part.
It really makes you think. How will advancements like this change the face of medicine in the years to come? Will AI become a standard part of the diagnostic process? How will it impact the role of human doctors? These are big questions, and it's going to be fascinating to see how things unfold.
Absolutely. We're just at the beginning of this journey, but it's clear that AI has the potential to revolutionize the way we approach healthcare.
Well, that's all the time we have for today's deep dive. As always, thanks for listening. And before you go, think about this. What would it mean for you as a patient to know that AI is playing a role in your diagnosis? Would you feel reassured or a little uneasy? It's something to ponder as we enter this new era of AI-powered medicine.